Hi, so this is how to start a jet flame and to try to get the least amount of smoke when you're starting it and then to generate the least amount of smoke when you're running it. It makes a big difference what size the sticks are. And so here are three different size sticks. This one is a little over 1/8 wide. This is 2 centimeters by 2.5 centimeters, and this one is 4 centimeters by 4.5 centimeters. If you use the big stick, it probably makes the least amount of smoke, but it generates the smallest amount of flame, and therefore you have lower firepower. If you want to really get great firepower, you burn little sticks. It makes a tremendous amount of flame, but it's going to make a lot of smoke at the same time. And so if you want to run a jet flame with a good compromise between firepower and smoke, 2 centimeters by 2.5 centimeters is a good compromise. And so we're going to use 4 of those sticks at a time. And these 4 sticks are long enough that you can boil the water. So for an IWA test, these sticks are long enough, and so we have 457 grams of wood right there, and that's going to be enough to boil the water for a IWA 4.2.3 water boiling test. All right, so this is made charcoal. And the reason I am saying that is because all of the wood's been burned out of it. This is what is left over after we do a test. And so Kim has put 30 grams of charcoal there. And have you poured the...
Nope.
Okay, why don't you pour on there. She's going to put 15 grams of alcohol on there. And she's doing it in the tray so that it's all absorbed on there. And so it doesn't run into the jet flame and set the motor on fire if the jet flame is tilted the wrong way. That's why it's really important to tilt the jet flame so the end of it where the fan is above the fire. So now Kim is putting the charcoal in the rocket stove, and you just do it from on top. And then I'm gonna take a little stick of wood, Sam, and just push it to the back so that it's a pile. I want to have it be pushed to the back, and so when I push the sticks up against it, they light from the tip. I don't want to put the sticks on top of the pile. I want to stick them into the square end of the pile.
There you can see the stick whirling from the top of the stove, and there's the charcoal and the sticks right next to it.
How do you get 50% thermal efficiency in a low mass stove and 40% efficiency in a higher mass stove? You use a tall skirt and a aluminum pot. The aluminum pot in this case is 28 centimeters, so it's a pretty big pot. We put 5 liters inside, and then this is a 6 mm channel gap, and we have a very tall skirt. Maybe the skirt is 6 inches tall. And so the heat is hitting the bottom of the pot, and it's going up through this very restricted channel gap, which is giving us good heat transfer efficiency. I'm now going to light the charcoal with the alcohol on it. Okay, there it lit. Now I'm going to turn on the jet flame. There we go. Then I'm sticking the sticks in, and I'm having the 2 centimeter part go into the pile. And so I'm lighting the sticks on the tips. You see that, Sam? How it just, even though we took our time, that just gets, that charcoal gets blasting hot.
Yeah.
And that's what lights the tips of the sticks. And because we're lighting it at the tip, we're making the least amount of smoke. And then I'm just going to push them in, you know, relatively fast, but just trying to not make smoke. And we'll get up to, what is it, 4 or 5 kilowatts.
So now we're looking at live graph where we have the last test. So this was the CO2, the firepower proxy we had from the last test. We had the water temperature going up and the low CO in the red, and almost no PM we're detecting with our light scattering and the black line. And then we just started the stove back up, so we still have no start emissions. We have this very small bump. If you do that with paper or with pieces of wood or even too much kerosene, you'll have a very big spike in the middle. You'll have a very big spike right here. So then we have the CO2 is rapidly increasing. We start up very fast. Then we have this target CO2 or target firepower for the test. And we're going to continue with the stove test. Alright, so Dean is pushing in the sticks slowly and he's making sure there's air between each stick. Right now a lot of that starting charcoal is still burning, so I have to be sure to push the sticks in fast enough as that charcoal burns down, make sure those sticks are going. The sticks are going though, so it's not going to go out.
And then what replaces it, you can see the charcoal at the end of the tip. That charcoal is going to replace the charcoal that we put in the pile. And the other thing is, the flame above the fuel is what makes it clean. So if this is not like a normal fire, you want flame above there to, it cuts both the PM and the CO. If you just have charcoal burning without flame above it, you're actually making a lot more PM along with obviously CO. So you want to keep flame above the sticks. And that, when we talk to people about primary air, maybe what's going on is something called pre-mixing, something like pre-mixing. You can see that the fuel is really changing right away into flame, which is well mixed. And so just with primary air, you're getting very high temperatures, and you are maybe getting something like pre-mixing.